All right, so I think we are going to start this session today. So welcome back to IEEE Science 2020. So this is session 2, and Molly and I will be your hosts this morning. So this is track 4, Human Factors in Visual Analytics. We will have 2 talks this morning, then a 60-minute break, and then 2 more talks this afternoon. So our first presenter is going to be Cossi Blaise Avoussoukpo, and he's going to present towards an aggregate signature-based authentication for opportunistic networks. So Cossi, whenever you're ready, go ahead. Cossi, I think you're muted.
Can you hear me, please?
Yes, we can now hear you.
Okay. Hello, everyone. I'm honored and privileged to participate in this conference, especially at this particular time. We are grieving with people around the world that have lost lives. My presentation is I can control. Yeah. I think there is a problem. Okay. Okay. Can you hear me? I said I'm privileged and honored to participate in today's conference at this particular moment where we are grouping with people around the world that have lost, their kids and kin, their flesh and blood. This evening, because it's 6 here, I'm going to present the primary level of our research about securing opportunistic networks titled Towards an Aggregate Signature-Based Authentication for Opportunistic Networks. In the introductory part, we are going to talk about the concept of opportunistic networks, the characteristics of opportunistic networks, the challenges of opportunistic networks, the application of opportunistic networks, the differences between opportunistic networks and other networks. Afterwards, we are going to present our scheme, followed by security analysis, conclusion, and future works. The concept, now we will brief people with the concept of opportunistic networks. The various breakthrough in communication, together with the increasing number of smart devices in use, have given rise to many concepts. The concept of Internet of Things, with its derivative concepts such as the industrial Internet of Things, the Internet of Vehicles, and the Internet of Everything, came as a poor ideal that is supposed to integrate several complex technologies. On the other hand, the advances in wireless networks and infrastructure networks, birth, mobile network networks, and its derivative concepts such as self-configured networks and the directory networks. We opine that the Internet of Things and mobile ad hoc networks fathered opportunity networks. Opportunistic networks rely on devices discovery. And the most important, the vital component of opportunistic networks is what we call seed opponent. Some researchers call that vital component seed opponent or seed node, but we think that the better terminology to name the seed opponent or super, the seed node or super node is seed opponent. Now, here, I'm having some difficulties. I don't know what's going on. It's moving. I can, okay. 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 I was talking about the vital component of an opportunistic networks, that is a seed opponent. A seed opponent determine or establish the opportunistic networks. The seed opponent determine the goal of the opportunistic networks, and any seed opponent is supposed to expand, inviting resourceful nodes, users, or devices that have the capabilities to help a seed opponent achieve its goal. So that's how opportunity networks start and expand. So to have an opportunity network, we need the vital component, that is seed opponent, that determine the goal of the opportunity networks, that invites resourceful node, users, or things that come together to achieve the opportunity network's goal. An opportunity networks or opportunity networks generally are different from other networks. Of course, opportunity networks are self-configured. They are self-configured. They rely on little or no infrastructure. And some researchers call opportunity networks an evolution of mobile network networks. Mobility, that is a challenge for other networks, is an opportunity for opportunity networks. Opportunity networks component that we call helpers. I'm talking about nodes that are invited to form the expanded opportunity networks are not deployed all together. They come one after the other, depending on the need of the seed of the seed opponent. And the most important thing is that opportunity networks realize opportunity growth and the opportunity use of that growth. In other words, all resources are put together in an opportunity networks. It's not just a mere opportunity communication. They communicate opportunistically, but the most important is the get together of their different resources. Opportunity networks can be used in emergency situation, in military operation, in remote healthcare assistance. For instance, in our current situation of pandemic, if opportunity network could be used, if well researched on, could be used to help solve different problems, like sharing information, like assisting people during this period of pandemic. Now, let's come to the challenges. Opportunity networks are challenging networks due to the nature of self-configured, relying on little or no infrastructure. So opportunity networks need appropriate routing protocols, appropriate routing protocols that could meet opportunity networks demand. Also, when it comes to privacy, identity protection, social life protection or location, there is a need for algorithm, for schemes, for protocol. And when it comes to authentication, we have two types of authentication: helper authentication within an expanded, or let's say within an opportunity networks, and we also have like helpers seed opponent authentication. Helper authentication means within an opportunistic networks, two nodes or two things can communicate. During that communication, they need to make sure that they are not communicating with the wrong thing. Also, we have here helper seed opponent authentication. That's the communication between helpers and a seed opponent that design or establish the networks. Here in this article, we are concerned with helpers seed opponent authentication. Now let's come to our motivation and our contribution. Opportunity networks are particular networks where independent nodes come together within the supervision of a seed opponent to achieve a precise goal. Since certified or registered node are allowed to help a seed opponent achieve its goal, making sure that unauthorized users do not come to disrupt the smooth completion of a seed opponent's goal. Authentication, helpers authentication is critical. Also, despite all the contribution in the domain of, in the research domain of opportunistic networks, only helper authentications protocol or system have been proposed. There's no, in literature, there's no article tackling the issue of helpers all together with a seed opponent. On the other hand, digital signature has proven to be one of the most important primitive in asymmetric cryptography due to the security goals, due to their security goal of authenticity, integrity, and non-repudiation. So resulting to digital signature to secure an opportunistic networks environment is very important. Also, we know that within an opportunity networks, the seed opponent has to deal with many helpers. Since they have to deal with many helpers, when we use digital signature, that means a seed opponent has to deal with many signatures at a time. So, resulting to an aggregate signature could ease the burden on a seed opponent. Blaise signature has a shorter length as compared to other digital signatures such as DSA, RLC, LKMA. So that's why we consider using BLS signature and its aggregate form to propose an authentic, helpers seed opponent authentication within an opportunity networking environment. Our contribution in most proposed scheme, authentication scheme proposed in the domain of opportunity networks most researchers just use the terminology of the seed node or super node. Here we replace that terminology with seed openet. Seed openet means things coming together to determine or to design, to establish like a group that with a precise aim, a precise goal. We give the seed openet an identifier, and we also give each helper a unique identifier or identity. Here, our main contribution is helpers as a whole and seed openet authentication. Our proposed scheme is based on some assumption. Given the fact that opportunity networks is relatively new, we need a lot of assumption. Like here, users represent devices, represent things, represent nodes, and vice versa. Each user, node, or thing has a single unique identifier. Here, network connection are not discussed. And we suppose that each things understand some basic and has the capacity. Each thing understand the basic cryptography. Each thing has the minimum computation capability. We also suppose that the seed openet has what it takes to successfully complete the registration authentication and aggregation and verification process. So here is all the organigram of our proposed scheme. We have registration. So we know that we know that in within when the seed openet is established and when the goal is determined, the seed openet needs to invite potential helpers to help them achieve their goal. So only certified node are allowed. So registration is very important. So during registration, in registration we have key generation, we have request, we have index number reception, and after registration we have authentication. Authentication we have that's the main goal of our paper. But we have signature, we have aggregation, we have verification, and then afterward we release we release the nodes. Our helpers are released. Okay. Now, here we have registration. In registration, we have node I, and the seed openet. They all come. We suppose that they all understand. They all understand. They have the understanding, a complete understanding of basic cryptography. So node I comes with both its public and node I is capable of generating its public and private key, and also node I has an identity, so that the seed openet. Now the seed openet, although made up of different devices, have a unique identifier. We suppose that they have the capability to do so. So here, node I send a request to the seed openet, and the seed openet. But here, the seed openet could also send a request to node I. So upon reception of that request, the seed openet sends its public key to node I. Node I, after ample reception of that public key, sends its public key and together with its identity to the seed openet. The seed openet will unlock that package, receive node I's public key, and identity, and then prepare node I's credential. So node I will receive a package from the seed opponent that's made up of the seed opponent's identity and an index number. Ample reception of all these things. Node I is certified. Node I is certified, then there is a member becomes a potential helper, and at that time, Node I will put its resource will avail itself to the extended seed opponent or opportunistic networks. So Node I now could sign messages, could do anything according to the need of the seed opponent. Now here comes an example of a brief example of the authentication process. For a given matter, the seed opponent prepares an information request that will be sent to helpers. The seed opponent sends an information request to each helper using the public keys. Each node or helper using its private key to get the content of the information. Ample reception of the content of the information sent by the seed opponent help us prepare the share of information. Here, we should know that the resources that each helper's resources are different because the seed opponent look before inviting helpers, look at how helpful a helper is or a potential helper is. So when the helpers pieces of information or information ready, we prepare the package with the digital signature and send the package to the seed opponent. The seed opponent will now unlock the package, aggregate the signatures, and verify. So the seed opponent will trust the information received if all this equation hold. We are not going to go into the details, but this equation that are here. But here it's very important to understand that helpers messages are different. They don't have the same capabilities. They don't have the same resources. They have different resources. So they will always come up with different messages.
We have 1 minute left, Cossi.
Okay, yeah. So here, for security analysis, the security of our proposed scheme is based on the security of BLSCH and its aggregate form. Here we have proposed a scheme. That has the advantage to help a seed opponent to process at once data transmitted by helpers instead of processing these pieces of information one by one. Opportunity networks are new, still new, and like we can say, virgin ground because there is a need for standardization. There is a need for versatile communication technology. There is a need for universal aggregator because when things are are moving. We don't know their capabilities. So our proposed scheme is the first idea is still theoretical. So we plan to work on to improve the proposed scheme at a theoretical level and research the simulators that best fit optimization networks requirement and demand, and later we will conduct robot analysis, simulation, and that's it. Thank you.
All right, thank you, Cossi. So do we have any question? Do we have any questions from our attendees? There's no question as of yet. So to come back to your universal aggregator, what will you improve into the universal aggregator? What are your next steps?
Yeah, because now I don't think I have such what we have, and the article in about universal aggregator. I just saw one, so and that one is not finalized. So, and I think that universal aggregators best fit opportunistic. Could be used in opportunistic networks. So my ideas are not clear yet about universal aggregators, but I know that universal aggregators could be used to help devices like aggregate pieces of information. But till now, my idea is not clear, because in literature there's no clear idea. I have not seen any article, so I'm working on that. And I'm still researching, I'm doing the maths about it. And I think if something good is, anyway, it's an open field, it's still an open field of research. And I know that finding or designing an aggregator, a universal aggregator could be used to, facilitate communication and within an opportunity network environment.
Perfect. Well, thank you very much for this presentation. And then we are going to move on to our next presenter, Fiona Carroll. Then, thank you, Cossi.
You're welcome. Yeah.